Hello class, today we're going to do chapter 5, number theory in the real number system, and go into chapter 5.5, real numbers and their properties. We are not going to get into the clock addition. It's not going to be something we decide to cover in this course because honestly we do regular clock addition, but the clock addition associated with this particular chapter is just not something you really see notated in your real life circumstances. So if it's not really used in real life, sometimes I tend to stick away from it. Our objectives are going to be objective 1 and 2. Recognize subsets of the real numbers and recognize properties of the real numbers. Like I said, not covering the clock addition properties. Hopefully you do know your clock addition. The way it's taught within this particular textbook, to me, isn't worth covering because it is not used in real life in the particular application and symbols which they use. So I'll stick with the first couple slides here and cover those first couple bullet points. The set of real numbers, the union of the rational numbers and the irrational numbers, is the set of real numbers. The set that make up the real numbers are called subsets of the real numbers. So let's look at this. Real numbers. Okay, all of these are sets of the real numbers. Rational numbers are sets of the real numbers. Integers are sets of the real numbers. Whole numbers are sets of the real numbers. Natural numbers are sets of the real numbers. And irrational numbers are sets of the real numbers. Okay, all of these are real numbers. Okay, rational and irrational numbers are separate. Integers are a type of rational number. Whole numbers are a type of integer, which is a type of rational number, which is a real number. And natural numbers are a part of the whole numbers, which are part of the integers, which are part of the rational numbers. So just smaller and smaller subsets, essentially, of each set. Let's consider the following set of numbers. We have -7, -3/4, 0, 0.6 repeating, the square root of 5, pi, 7.3, and the square root of 81. We need to list the numbers in the set that are natural numbers, whole numbers, integers, rationals, irrationals, and real numbers. So let's see if we can list all of these sets given our initial set. I put this into a table format to try to make it easier. Natural numbers are basically your natural counting numbers. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The square root of 81 falls into the natural numbers because the square root of 81 is the number 9 if it is simplified. And 9 is a natural number. Therefore, the square root of 81, which is 9, is a natural number. Natural numbers are numbers, once again, 1, 2, 3, 4, 5, 6, 7, 8, 9. Whole numbers are numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So whole numbers and natural numbers are very similar, but whole numbers include the number 0. And that is our whole rationale here in including this 0 point right here into our whole number set. So our whole number set includes 0 and the square root of 81. Remember, all natural numbers are included in whole numbers. But in addition, we also include the number 0. Now, integers are both positive and negative whole numbers and 0. So what we're looking at here for integers is the 0, the square root of 81, everything included in the previous set because those are subsets of the integers, and also this negative integer here at -7. Okay, got to be sure to include it. Because integers include whole numbers and negative natural numbers, we include 0, square root of 81, and -7. Now let's look at rational numbers. Remember, rational numbers are any number that can be written as a fraction or a terminating or repeating decimal. Okay, so rational numbers include all the numbers so far because integers, whole numbers, and natural numbers are all rational numbers. So our rational numbers here are 0, 81, -7, everything included in our previous sets, but as well it includes the fractions, so it includes -3/4. It includes repeating and terminating decimals, so 0.6 repeating and 7.3. If I look at my irrational numbers here are the square root of 5 and pi, essentially the leftover numbers that aren't rational. Okay, the square root of 5 is not a perfect square and therefore is irrational. Pi is not a terminating or repeating decimal, therefore is irrational. Okay, make sure you say that right. Anna. You can easily confuse rational and irrational. Irrational, square roots that aren't perfect square roots, and decimals that aren't terminating or repeating. Because neither terminate nor have blocks of repeating decimals or digits, the square root of 5 and pi are irrational numbers. Real numbers. Now, every number in the set above is a real number. All rational and irrational numbers are real numbers. Because real numbers have all of the above numbers as subsets, all of the above numbers are therefore real numbers. So it's everyone in the set. So let's look at some properties of real numbers. We have the closure property of addition. The sum of any two real numbers is a real number. So the square root, or 4 square root 2 is a real number, and 5 square root 2 is a real number. Therefore, 4 square root 2 plus 5 square root 2, or if you simplify it to the square root, or 9 square root 2, that is also a real number. So real number plus real number gives you another real number. We also have the closure property of multiplication. The product of any two real numbers is a real number. 10 is a real number. 1/2 is a real number. So 10 times a half, or 5, is also a real number. So if you multiply any two real numbers, the result of that is going to be another real number. The commutative property of addition says that changing the order when adding does not affect the sum. A plus B is the same thing as B plus A. So 13 plus 7 is the same thing as 7 plus 13, which makes sense because they both equal 20. Also works with square roots. Square root of 2 is the same. Square root of 2 plus square root of 5 is the same thing as square root of 5 plus square root of 2. Don't believe me? Type both in the calculator. They will give you the same answer. Commutative property of multiplication. Changing order when multiplying does not affect the product. AB equals BA. So A times B equals B times A. 13 times 7 equals 7 times 13. Or the square root of 2 times the square root of 5 equals the square root of 5 times the square root of 2. The order does not matter in multiplication. That is the commutative property of multiplication. Next, we have the associative property of addition. Changing grouping when adding does not affect the sum. So parentheses A plus B, close parentheses, plus C is the same thing as A plus parentheses B plus C, close parentheses. The ordering here, or the grouping, does not matter with addition. You can group the first two terms or the last two terms. If all you're doing is adding the terms, the grouping does not matter. The final sum will come out to be the same. So 7 plus 2 plus 5 is the same thing as 7 plus 2 plus 5, because the grouping of 7 plus 2 is 9. 9 plus 5 is 14. And the grouping of 2 plus 5 is 7. And 7 plus 7 is 14. We also have the associative property of multiplication, which says that changing the grouping when multiplying does not affect the product. So parentheses A times B times C equals A parentheses B times C is the same thing. So if we look at 7 times 2 times 5, does not matter the order that I group these. I can group 7 and 2 together first, or I can group 2 to 5 together. 7 times 2 is 14, times 5 is 70, or 2 times 5 is 10, times 7 is 70. The grouping does not matter. That is the associative property of multiplication. Let's look at the distributive property of multiplication over addition. This is a very, very important property. And if you do continue into mathematics at this university, you will vastly use this property and rely on it going forward. So please, 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 if you need extra practice I encourage you to delve further into this property and make sure you have it down pat. The distributive property of multiplication over addition. Multiplication distributes over addition. If we have A times B plus C, I need to distribute that A to that B and that C, so that it looks like A times parentheses B plus C equals A times B plus A times C. So if I look at this in an actual problem, it says 7 times the parentheses of 4 plus the square root of 3 is the same thing as 7 times 4 plus 7 times the square root of 3. 7 times 4 is 28. So that reduces that piece, and the other piece is simply 7 square root 3. So our final answer is 28 plus 7 square root 3. Distributive property is extremely important, and you will use it almost every day in Math 108 if you continue forward in that direction. The identity of property of addition. 0 can be deleted from a sum. So A plus 0 is the same thing as A. I can simply get rid of the 0. 0 plus A is simply A. I can just get rid of the 0. So if I look at the square root of 3 plus 0, I get the square root of 3. If I look at 0 plus pi, that is simply pi. I can simply delete the addition of 0. I will also look at the identity property of multiplication. 1 can be deleted from a product. So if I have A times 1, that is simply A, or 1 times A is simply A. So a lot of the times we represent this 1 out front by simply writing the number. So here, A times 1 is A. We don't write the 1. 1 times A is A. We don't write the 1. So if I look at the square root of 3 times 1, I'm simply just going to write the square root of 3. If I look at 1 times pi, I'm simply going to write pi. And another one that's important going forward, if I look at 1 times x, a variable, I'm simply going to write x, and the 1 is understood to be out front. Let's look at the inverse property of addition next. The sum of a real number and its additive inverse gives 0. The additive identity. A plus negative A gives me a 0, or negative A plus A gives me a 0. Square root 3 plus negative square root 3 gives me a 0. Negative pi plus pi gives me a 0. If you add something and its additive inverse, essentially if you add something and then you take the negative of that and add it to that, it just cancels itself out to be 0. The inverse property of multiplication says the product of a non-zero real number and its multiplicative inverse gives 1, the multiplicative identity. A times 1 over A equals 1. So we're looking at the multiplicative identity here. The multiplicative identity of something is just 1 over that something. So here the multiplicative identity, the multiplicative inverse is 1 over A. So we have A times 1 over A, its multiplicative inverse, and that simply renders 1 because the A's cancel out as long as A is not equal to 0. You can also do it the other direction, 1 over A times A, that also equals 1. So if I'm looking at the square root of 3 times 1 over the square root of 3, that is simply 1. Or if I'm looking at 1 over pi times pi, that is simply 1. Essentially, the way I like to think about it is the square root of 3's cancel out and they leave you with this 1. Or the pi's cancel out and they leave you with this 1. Let us name the property that is illustrated. Here we have the square root of 3 multiplied by 7, and that is equal to 7 times the square root of 3. You can easily identify that it's some type of multiplication property. Here, this is the commutative property of multiplication. The next one shows us parentheses 4 plus 7, close parentheses, plus 6 equals 4 plus parentheses 7 plus 6, close the parentheses. Here, we're dealing with addition. So it's some property of addition. This is the associative property of addition. You need to know your property definitions and what they look like. C says 2 times 3 plus square root of 5, with the 3 plus square root of 5 in parentheses, equals 6 plus 2 square root 5. This is one of the most important properties that we discussed earlier. This is the distributive property of multiplication over addition, because here what we simply did was to distribute the 2 to both terms. 2 times 3 is 6. 2 times square root 5 is 2 square root 5. The distributive property of multiplication over addition is one of the most important properties you will learn. 7 plus negative 17 equals 0. This is once again a property of addition. It is the inverse property of addition. Be sure to familiarize yourself with all properties of real numbers that we have gone over and be able to identify them and how they work. Also, be able to use them, especially, once again, the distributive property. This concludes our chapter 5.5. We will continue next time with chapter 5.6. If you have any questions, please don't hesitate to reach out to me by email. I hope y'all have a good rest of your day.